record, share, and we're off. So, like I said, we're going full bore now. I know that I kind of teased it in and we started Unit 3 about a week ago. So we did that first thing. We kind of got an essential skill out of the way that'll make the rest of the chapter better. Today, we are not going to talk about y equals mx plus b. Today and tomorrow are dedicated to one sweet mission, and that is, can I get all 55 of my algebra students to master the art of finding the slope of a line? And honestly, it might even take more than 2 days. I feel like this needs to be a non-negotiable as far as this unit is concerned. And there's other units that utilize this as well. If slope isn't something that you're really good at, then lines, inequalities, all that stuff, systems of this, systems of that, it's all just going to be 10 times harder than it needs to be. So today we're going to take the approach. Today is what, October or November 6th. And we are going to be finding slope today, but we're going to do it without any graphing. Okay. I'm honestly doing this backwards because I like to try new stuff when I feel like things need changing. So this year I'm going to try teaching you slope without looking at graph paper. Have you guys ever heard of slope referred to as rise over run?
Yeah.
Yeah. So we're gonna go a different route today, and we're gonna go with just the strictly mathematical perspective on slope. And so today is slope with no graphs. And I'm gonna put a formula on the board, and I'm gonna see, especially do I have eighth graders in this hour? I always forget. Yeah, just you, right? Just the one.
And Hannah.
And Hannah, but she's in like where Florida. Yeah, she's on a beach or something like that. So you ninth graders will recognize this formula that I'm about to write. I hope, I would assume. I feel like this is something that you talk about in eighth grade. Is that correct? What's up,
I've
sir?
never seen this. We just skimmed over it.
I think he probably did too. As with everything that we have overlap from eighth grade to ninth grade, I will never ever teach a lesson and base the content or the tone of my lesson on any assumptions that you know it. I'm going to teach this lesson as if you don't even know what slope is. Okay. So if you've seen this formula before, really it's just another way of saying what we talked about the other day. And that is quite simply, we're just finding the change in the y coordinates and we're dividing it by the change in the x coordinates. Just going to give you a real quick glimpse at how slope works, and then I won't talk about lines anymore after this. But if I'm going to put 2 purple dots on the board, and I want you to tell me if I drew a line through the points, would the slope be positive or negative? Are you ready? Go. Negative, right? And so when we get more into the graphical aspect of this, then we're going to talk about rise and run. Like we're literally going to count the distance to go from one point to the other. Like we will count out the rise, which is an up and down motion, and then we'll count out the run, which is a sideways motion. But today we're doing it all sort of behind the scenes, right? So you know that any 2 points that are in that pattern make a negative slope because it's clearly going, well, downhill, right? How about these 2 yellow points? Is that slope positive or negative? It's neither. It's a number. It's called 0. So right in between an uphill line and a downhill line lies what we call a horizontal line. And horizontal lines have a slope of 0. If you're driving on a road that is literally flat, then we would say the slope or the grade of that road is 0, right? You're not going up and you're not going down. How about the green dots? Positive, right? Because it's going uphill. And then the final kind of slope, there's literally only 4 things that straight lines can do. They can go uphill, or they can go downhill, or they can be horizontal, or they can be vertical. And if I gave you a couple of dots like these 2 red ones, does anyone know what the slope of that line would be?
0.
It has no slope, and it is not the same as 0. 0, the number, is reserved for the yellow dots. If 2 points or a line are vertically aligned with each other, then slope does not exist. The word that people sometimes use is undefined, or you can say what Josh said and say there is no slope. Either one of those means the same. A But you can't say zero, remember, because zero is reserved for the yellow dots.
Can you
So-
say nothing?
Okay, say again.
Can you say nothing?
No, you need to say like no slope or undefined. Yeah. Is that what you learned? Undefined? Cool. Yep. And I can go either way on that. Just remember that, like, sometimes people think, well, if you have no slope, then you have zero slope. They're not the same. Like, I agree that if I went to the lounge and I looked in a box and I was like, oh, there's no donuts, like that means there are zero donuts. It doesn't work that way with slope. Okay. No slope means it does not exist. It cannot be mathematically defined. So that's all I wanted to say about that. Now we're going to get into the mathematics of the behind the scenes stuff. We're not going to be counting rises and runs and making cute little staircases today. We're going to approach slope today from a strictly numerical perspective. Lots of subtraction, lots of reducing fractions, real basic math today. So let's get to it. I have some examples for you, 6 or 7 of them, 7. And we're going to walk right through them. And I hope that this lecture covers all bases so that when you get to your assignment, that you don't encounter things and go, hey, we didn't talk about this. I tried to incorporate everything into this. Uh, so this formula, the red formula, can be a little bit daunting. Let me put an example on the board and then I'll show you how to label your points. And you don't have to do this every time, the labeling. I'm just going to show you since I'm recording and you're listening, and then we'll go quicker after this. So our first example is going to be these 2 points. Bless you. Now, again, if we were graphing, then I could go to a piece of graph paper and I could plot those points. I could go right 3 up 4 and put a dot. And then I could go right 5 up 5 and put a dot. And then I could physically, literally count the staircase, rise and run between them. In the absence of that, we're going to use the red formula at the top of the board. And that is y2 minus y1 over x2 minus x1. Now, if you've never done this before, you might be wondering, what in God's green earth does y2 even mean? Well, this is y2. Why do you think we call that y2? Could not have said that better myself. It's literally the second y. What a great name for it, y2. So what do you think the other 5 is? That's x2. It's the second x. What is the 3? And what's the 4? Good job. So if the formula ever feels to you like this weird thing that some dude in a cave, with a long beard invented, it's not like that at all. It's just literally saying, find the difference between the y's and find the difference between the x's. The key to this is consistency with the direction that you go. So that's why we give you this little formula to hold on to. And I'll show you in this example what I mean. So if I am very literal about the red formula, I'm going to take the y2 minus the y1. And if you look at the TV and not my face, then you'll notice that there is a subtraction problem modeled by that purple arrow, right? And I'm literally modeling y2 minus y1. That's what the arrow represents. So I'm going to write that down. y2 minus y1 can be replaced with the math problem 5 minus 4. And that goes on top. And then I'm going to find delta x, which is x2 minus x1. And this can be represented by the yellow arrow, which is 5 minus 3. And don't think for a second that I'm not capable of knowing what those answers are, but I'm telling you, we're going to have more success if we don't just always jump right to what the answers to these are. As you'll see, as the examples get harder, it's important to let ourselves see the work. And now we can get right to it. For our change in y, 5 minus 4, what do we get? And for 5 minus 3, 2. So we say that the slope m equals 1/2. And you can ask me if you want, why do we use m for slope? Does anyone want to ask? Good, because I don't have an answer. I have no idea why someone chose m for slope. It happened long before my time, and mathematicians long ago elected to call certain things by certain letters. And I've Googled it, and I'm not actually sure what it stands for. I don't know why. It seems arbitrary that it would be an m, but that's what it is.
Oh, what's easier, doing the numerical version or the actual slope?
You mean on a graph? I like the numerical because I don't like graphing stuff. Like, I think it's tedious to get out a piece of graph paper and plot points, and this is just easy for me, and it'll probably be easy for you as well. So the graphing is nice. Like if you already have the points, and you can just look at them, it's pretty slick and quick that way. But if I'm the one that's got to get out the graph paper, like I would always choose this, right? Less hassle. So there, one down, six to go. Do you have any questions? Would this line go uphill or downhill?
Up.
It would go uphill because this slope right here is a positive, and positive slopes are always lines that go uphill like that. Got it?
Yeah.
Good. Let's do another example. -2, 5. And the other point is 6, 1. What will the top subtraction? I don't want the dang answer. What will the top subtraction problem say?
1 minus.
Nice, good man. Y2 minus Y1 is 1 minus 5. Thank you for that. Now, this is where the trouble starts, especially with speedsters that are like, I'll show you, I'm faster than you. What will the bottom math problem say?
6 minus.
Yeah, it actually says 6 plus 2. And that's where some confusion can start. Because you could look at that red slope formula from your notes, and you could look at it all day long, and I dare you to find me a plus sign in that formula. But let's take a quick deep dive and see why that happened. What's happening there is it was really this, and that is 6 minus -2. And if the target number after a subtraction is a negative, then we know that a minus and a negative come together to make a plus. So sometimes your little slope formula actually involves addition. What's 1 minus 5?
Negative. -4.
-4. And what is 6 plus 2?
8.
And that is not an acceptable answer because it can and needs to be
-1.
reduced. Good. So the slope in this case is -1/2. So far, so good. As you sit and learn this, would you agree that this is not difficult?
Yeah.
You would be amazed how much trouble this causes. And for 29 years, maybe my 29th year will be the year where I crack the code, but for all my other 28, I teach slope and I go through this and I feel like this is the year. And then the trouble starts. And I'm always like, I wonder what I did wrong. So don't underestimate this. I can just tell you from experience that we sit here and look at it and think, God, a fourth grader should be able to do this. Something happened. There's something weird about it, and I don't know what it is. Let's keep going and let's keep rocking some answers. So that's 2 down, 5 to go. Next one, we have -5, 7 and -5, 3. What would the subtraction problem be on the top of my fraction?
3 minus 7.
Good job. What would the subtraction problem be? I should be less specific. What would the math problem be on the bottom of the fraction?
Minus
-5 plus 5.
Good job, Keith. -5 plus 5. And again, that comes from this minus this. -5 minus -5. There it is. Nice play. And now it's time to do some low grade simple math. What is 3 minus 7?
-4.
What is -5 plus 5?
0.
I don't know if you guys are aware of this or not, but there was a thing in Mr. Manlove's room. He's got hanging on his wall. I believe it's called the 10 Commandments of Mathematics. Have you ever seen it over there?
Yeah.
And I'm pretty sure that if it's not at the top, it's near the top. One of the commandments is thou shalt not divide by 0. Whenever you get 0 on the bottom of a fraction,
Divide by -4.
this is undefined. For those of you not taking notes for whatever reason, again, that is your choice, but I would recommend that if you're going to write anything down, you write this down. You're going to get this very frequently, that you go and you find the slope and you're like, what the heck? I just got a 0 on the bottom of my fraction. When you get a 0 on the bottom of your fraction, that means that the line would be vertical. And as we discussed about 10 minutes ago, vertical lines have undefined slopes. How else could I say it if I didn't want to say undefined?
No
No
slope.
slope.
I could also say no slope.
What
What an interesting segue to our next example. Great question. So are we all clear? 0 on the bottom, no slope. And it's almost like Zurich could read my mind, but our fourth example, you guessed it, is one of those. So 8, 6, -2, 6. What would be the math problem that goes on top?
6 minus 6.
6 minus 6. What would be the math problem that goes on bottom?
8 minus negative.
Negative 2 minus 8, right? No switching to plus this time because it's a negative minus a normal number. No need to change to plus. What is 6 minus 6?
0.
And what is negative 2 minus 8?
-4.
Negative 10. When 0 is on the top, it is a horizontal line. And what is the slope of a horizontal line? Then the slope is the number 0. My esteemed colleague across the hall, for years, I've worked with him for 12 years now. And I can tell you this from my experience that he likes it when you guys spell out the word 0. I hate it. So stop it. Okay. It creeps me out. It would be like on a 3rd grade math test if you put, okay, kids, here's your math problem for the day, 3 plus 4, and your teacher required you to write this. Like, who does that? So listen, while I love him dearly, consider him one of my best friends, and respect the world out of him, once and for all, can we stop spelling the word 0? It's a number. Got it? Why? I just don't see the logic in spelling out. Again, I would say, why don't we just spell out all of our answers? If you want to keep spelling it out, I'm not going to stop you, and I'm never going to give you grief. I'll probably never say anything about it again, except for next hour. So if you like it and want to do it, please do. I just don't see the sense in spelling out some math answers. So enjoy if that's your thing. I won't give you any grief.
That'd be like writing out the whole equation with like whole letters, just like 3 was. Yeah.
So far, we have learned that we do y2 minus y1 over x2 minus x1. We've learned how to change minuses into pluses when we have to. And we've also learned that if 0's on the bottom, what do we put?
Undefined or
Undefined. And if 0's on the top, we put 0. Very good. Let's rock through these last couple, and then we should be good to go. Every problem that I put in my notes today had a different purpose, so stay with me, okay? And I'm not going to give you homework or anything, so we'll have a nice work day, I'm thinking, tomorrow, okay? So let's hang with me while we finish up these examples. We'll probably get a little bit of our math done today. All right. What's the math problem that goes on top?
3 minus 4.
3 minus 7 goes on top. And what goes on bottom?
-4 minus
Negative 3 plus 4. Right. And again, we're changing it to a plus because the number after the minus would have been a negative. So we know what's up. And as always, I mean, if you can't do 3rd grade addition, then algebra is just not going to be your favorite class, right? What's 3 minus 7?
4.
It is not 4.
-4.
It is -4 all day long. And what is -3 plus 4?
1.
So the reason this example made it onto my note card is because I wanted to make sure you guys all understand that the slope is -4, right? It has a purpose sometimes for calling it -4 over 1, because like when you go to graph, it makes sense to say like down 4, right 1. But overall, if we're just going to say the slope, we should just put the best, cleanest answer that we can. So -4. All right, next one. 2. -8. 10. 0. Top math problem is, it is not 0 minus
8
8.
minus -8 minus 0.
Listen, we're going to do a lot of these problems together, and I lied. I said I was going to show you both ways. I am a right to left guy. I'm a very literal user of the formula. So you're going to notice when I do this that I'm always traveling in the direction of these arrows. You can go the other way if you do it both ways, both times. I mean,
It's 0 plus 8.
I was waiting for someone to say that. Thank you. 0 plus 8 goes on top. And what goes on bottom?
10 minus 2.
10 minus 2. And then we have to just do basic little kitty math. What's 0 plus 8?
8.
What's 10 minus 2?
8.
What is this slope?
1 whole.
1 is the slope. Everybody got that? You don't have to write m equals every time. Sometimes not, whatever. And so the last one, I believe I wanted this one just so that we would have to reduce a fraction. That was the only reason I did 7 examples and not 6. I'm going to keep asking you this question because I don't want the answers to the problems, but here it goes. What is the math problem that goes on the top? 6 plus 4. Nice job. What is the math problem that goes on bottom?
2 minus 10.
2
Plus
plus 10. And we have to do math now. What is 6 plus 4?
10.
What is 2 plus 10?
Well,
And what is 10/12 reduced to?
5, 6.
So your slope on this one would be 5/6. Got it? There are 4 things that can happen. You can get positive slopes, negative slopes, 0, or undefined no slopes. That's all the things that slope can be. So we have about 12, no, that's a lie, 7 minutes of class left. Here's what we're going to do. By we, I pretty much mean you. There's an assignment on Delta Math. I put a lot of problems in it. I'd like you to see how many of them you can get done before about 10:53. All right, I'll give you a heads up when it's time to pack up. Sound like a deal? All right, then, let's do it. You shouldn't have to do every problem on paper. Like, I'm not going to really police that. Just don't get them wrong.